This is G481 Homework Booklet, question 30. Starting with the definition, define the torque of a couple. It is one of the forces times the perpendicular distance between them. The two underlined parts are important in order to achieve the marking point. Explain why moment of a force and torque both have the unit Newton meters. Quite simply, both quantities are calculated by multiplying a force by a distance. So we have newtons times meters. Now we see an irregular shape, a metal plate, and it can swing about this point P. The text confirms the details in the diagram, that the weight of the plate is 6 newtons. But we also need to look and see that two distances are marked, a 0.4 meters here and a 0.3 meters here. We are asked to calculate the clockwise moment of the weight about the point P. Looking carefully, you should see that the 0.3 meters is irrelevant. We want the force times the distance that is perpendicular between that line of action and the pivot. So it is 6 newtons times 0.4 meters. Do be careful, the units required were given in the question as Newton meters. It would be possible for an examiner to give you this information in centimetres, and you would be required to do the conversion to metres before you see the calculation through. Explain why the moment of the weight reduces to 0 when the plate reaches the bottom of the swing. Two ways of expressing this. You could say the line of action of the weight passes through the pivot, or the perpendicular distance between the line of action of the weight and the pivot is 0. It is essential to refer to the pivot in order to get the mark. Just glance back at the diagram and make sure that that makes sense. So the line of action of the weight is just vertically from the centre of gravity of the plate, and as this whole shape rotates like this, that line of action would end up being vertically below the pivot. Likewise, this distance here reduces to 0. Next, we're asked to describe an experiment how you could use this apparatus to find the centre of gravity of the shape. Just a few key points. Suspend the plate from a point, like the example of P shown in the diagram. Let it hang freely and then use a plumb line to mark the vertical line on the plate. You then need to repeat that process, so hang the plate from another point, draw a second vertical line, and where the lines cross gives the position of the centre of gravity. Now we have a new diagram showing a human forearm, and this text here is just confirming all the information given in the diagram. So it makes sense to read it through, and as you read it through, match each piece of information and make sure you're just interpreting it carefully. You're asked to take moments about the elbow joint and to use that to find the unknown force provided by the bicep here, this unknown force. If you look carefully, you are going to use the elbow as the pivot, and you have two forces that would make the arm rotate in a clockwise direction. These are in equilibrium with the unknown force, which would provide an anti-clockwise moment. So we have the 18 newtons multiplied by a perpendicular distance of 14. We have the 60 newtons multiplied by a perpendicular distance of 32, and the unknown force multiplied by a perpendicular distance of 3.5 centimetres. So we add the two clockwise moments and they will equal the anti-clockwise moment. Careful rearranging and solving to get the answer of 620 newtons. Notice in this diagram every distance was given in centimetres and I chose to use them in that particular unit. That's fine. Just remember, however, if you are asked to quote a moment and you're provided with the units, you need to check that you're working in units that will match the required answer.